So how does the table come to know of the presence of the duster? So when this duster is kept on the table gets deformed. This deformation we cannot see on this table, but had it been a rubber table, then we could have seen the deformation like this. The table does not like this deformation, so it wants to regain its original shape. Therefore, it pushes on the duster with an exactly equal force equal to the weight of the duster. This is how normal force acts. So what is normal reaction? Whenever a body pushes against the surface pushes on the body with a force called normal reaction that always acts perpendicular to the surface. So unless the body is pushing against the surface, normal reaction will not act. Suppose you got a table like this. This is exactly 90 degrees, vertically downwards. One block is hanging here. And there is a pulley here. So another block is sitting here. This block is not pushing against this surface. So in this case, the normal reaction is equal to 0. So normal reaction acts only when a body pushes against a surface. Normal reaction always acts perpendicular to the surface. And one thing we'll learn later, the line of action of normal reaction can shift to keep a body in rotational equilibrium. This mg will always act to the center of gravity, but this normal reaction can shift to keep a body in rotational equilibrium. If you apply a force here, then normal reaction can shift in that direction. Next important force is friction. Suppose we keep a body on a surface. And no attempt is made to slide the body. Then what is the frictional force between this body and this surface? See, the coefficient of friction between the body and the surface is mu. So what is the frictional force? The frictional force in this case will be 0. Unless an attempt is made to slide the body or the body is sliding, frictional force will be 0. See, if the body is at rest, frictional force cannot act either this way or that way. So frictional force has to be 0. Only when you apply a force to slide the body, then only frictional force will come into play. In the case we discussed earlier, when a block was hanging like this, we had seen that the normal reaction is 0. And if normal reaction is 0, it implies friction is 0. So friction can be 0 under 3 circumstances. First, when no attempt is made to slide the body, then friction will be 0. When the normal reaction is 0, then also friction is 0. And if the coefficient of friction is 0, then also the frictional force will be equal to 0. Now what will be the friction if a surface is made perfectly smooth? Will the friction become 0? surfaces are made perfectly smooth, the frictional force becomes very, very high. With all the molecules will come in contact with each other. However, in a problem of smooth surface means a frictionless surface, and a rough surface means a surface with friction. But remember, if a surface is made perfectly smooth, then friction will become very, very high. Next important force is tension. If you study tension properly, you will not have any tension during the exam. So let's try to understand tension properly. If a string or rope or cable or cord is tied to a body and pulled tight, the string pulls on the body with a force called tension that is always directed away from the body and which is directed always along the string. So this is what is tension. Tension has got some very important properties. First property, tension always acts away from the body under consideration. With a string, we can pull an object, but we cannot push an object. If I try to pull this block with the help of this string, I can easily do that. But if I try to push this block with this string, I will not be able to do that. So tension always acts away from the body under consideration. Suppose we have a simple system like this, where we have a pulley and two masses are hanging. Let M2 be greater than M1. Doesn't make any difference to our discussion. So on this object, tension will act in the upward direction, away from this body. On this pulley, tension will act in the downward direction. On this pulley, on this side also, tension will act in the downward direction. And on this mass, tension will act in the upward direction. Tension on this pulley will act in the upward direction here and downward direction as far as this top surface is concerned. Please understand, the same string is pulling this object upwards and pulling this pulley down. The same string is pulling this block upwards and this pulley downwards. This string is pulling this pulley up and pulling the top surface or the ceiling down. So tension always acts away from the body under consideration. Second important point about tension. Tension always acts along the string. This tension force will not start acting this way. This is wrong. Tension always acts along the string. Third very important point about tension. For a massless string, massless means mass can be neglected. For a massless string, tension is same at all points, provided all the pulleys in the system are massless. For the next 3 months, all our pulleys will be massless. So tension in a massless string will be same at all points. So these are the 3 important properties about tension. Tension always acts away from the body under consideration. Tension always acts along the string. And for a massless string, tension is same at all points if all the pulleys in the system are massless.